everyone. I'm Jonghwan Yu from YouTube, Yu Jonghwan TV on YouTube channel. Today, as I already noticed, uh, regarding the Berquist Sherman model, which is one of the most complicating model in my book, actually, the estimating unpaid claims are based on like basic technique and but I'm trying to tell you that what kind of adjustment we quite often used in an let's say the paid loss development triangle and case outstanding like loss development triangle. So accordingly, the reported loss triangle. And for the IFRS 17, people used to tell me that what is the best estimate of loss ratio, and that's one part of it. And probably uh, the Berkshire model is not familiar with the Korean practitioner, yeah, because it was dated back to probably like late 1970 in the US. There are two consultants. Oh, I will show you that original paper. This is probably published 1979, 1978 or 1979. And the the paper name is that loss reserve adequate testing. Here, reserve means, mostly the case outstanding. A comprehensive systematic approach. There's a title. So you can see the name, but we called it, Berquist Sherman. But there is two American consultants, actuarial consultants, James R. Berquist, Richard E. Sherman. Actually, this model, is dated back 1978, but it was not quite, known to all the actuaries in North America or Europe for a long time. The main reason that I can, make a good guess is that this model actually adjusts the previous, loss triangle, like pay loss or case outstanding, like those losses. What I mean by adjusting, people usually, say that in an, or quite recently, we restate the loss amount data. Restate means, we change it based on the whatever the trend factor or there is any other, adjustment to reflect the underwriting change or claim process change or regulatory change or any macroeconomic or socio-economic, environment change. And yeah, here is just one tip. When I just came back from Canada, uh, many people say that, on leveling of loss amount data. On leveling is only talking about the premium, or actually, why do you think, we use on leveling on the premium? I'm not talking about in detail, but we have to make all the historical data as apples to apple. The reason why we have at least 5 years or 10 years of data to come up with the any parameters to predict the future is that we we like more the data because we can see the some of the like trend or some of the like like let's say like a satisfied full credibility. The more data we have and the more accurate or the more comfortable our future prediction gets, right? So, uh, but when we use that, it's kind of hard to like treat like apples to apple or statistical term. Is it homogeneous or is like heterogeneous? So in that case, Berquist Sherman tried to restate the historical data based on whatever they call it, the trend factor. And yes, you should like remember back in 1978, probably the computer is not that good. I don't know, maybe like a like gigantic computer is at like IBM, but they don't have like such a small computer that has like much capability. Don't have it. So when I first read this paper, or when I first go through some of the like deterministic model of their own, and I was so shocked. Like it's a long time ago, and they're like very sophisticated adjustment based on some of the statistical technique, and their philosophy is like best one. I just try to let you read this one. While specific guidelines for reserve adequacy testing may be established, and specific examples of an actuarial approach to the testing of loss reserves may be offered for particular situations. Loss reserving cannot be reduced, this is the important part, to a purely mechanical process or to a cookbook of rules and methods. Actually, it was like 1978, but when I compare current situation in our own country, I regard it as, like this sentence reminds of us a lot of things. And yeah, I mean, I can just definitely recommend this paper for you to guys to read. But in the book that I translated, there are some like details. The author Friedland, uh, like show what the Berkshire Sherman did it in his book. So I'm gonna start with the basic data that we can start with. The original paper, there is a like a medical malpractice. It is a very volatile line, and it is one of the probably most complicating. When you look at the data itself, this is quite like surprising. And the paper title says reserve adequacy, meaning that I would like to interpret it as like case outstanding adequacy. I mentioned it earlier. The case outstanding for each individual claim case is set by claim adjuster, right? So that adequacy as a whole is quite important. And also that case outstanding adequacy plays a key role to differentiate the estimate of like ultimate loss or IBNR between PLDM and ILDM. I have already pointed out. And here I'm just gonna like demonstrate where we start from. So obviously we are given, let's say, paid loss, cumulative paid loss triangle, and case outstanding loss triangle. So here, before like when the Berquist Sherman adjust the reported loss, or actually like case outstanding or paid loss. Before adjusting, it says unadjusted reported loss. So it's sum of cumulative paid losses and case outstanding for each accident years as at each development period. So that's it. And you can see if I say this is $1,000 unit, this amount is pretty big, right? And also numbers are flying over there, especially in an earlier development. When you look at the, like link ratio, it starts from 1.7 and recently it rises up to 3.8 and 3.7. Yeah, I mean, obviously it has only like, you know, like 8 years accident year data, but when you look at here, it doesn't end there. So probably, to ultimate, it takes a little bit, longer. And even though I didn't put any, like tail factor here, or just, like illustrative convenience, and you can choose something. But here, you just, like select the simple average all 8 years. Let's put it that way to compare. This is, we can call it, this is a result from ILDM. And also we have unadjusted pay loss, cumulative basis. It's the same story. Amount is like, ups and downs all over the place. And here you can see even much more, volatility here. The smallest one is 3.2, but the biggest one is 15.7. Wow, it's like, oh my God. So I realized that why, Berkshire Shaman came up with this type of, like adjustment, restatement of the historical data, because, probably he got it from one of, their client, right? Because in America, probably 5,000 or 6,000 different PNC companies, and he has like much like smaller client and even bigger client. This medical malpractice has this type of feature. Actually, this one is also select. Oh no, this one is volume weighted average. So I would say it's like like basic chain letter. We just simply we don't do anything. We just like probably select a different, loss development factor, and we came up with this number. So this is ILDM and PLDM. So I just simply just doing like this. It's like 22.3% difference, which is quite a lot, right? When you look at this, like what, 23 billion or 48 billion US dollars, so it's a lot. And this amount of like difference, you cannot make the conclusion. As I already pointed out, this one is mainly from not 100%, but mainly from the inadequate level of case outstanding figure. So what they did was, like to like restate the case outstanding loss triangle. So I say restate, right? So we don't do apply on leveling on the losses. That's only for the premium. And like a claim side loss amount, we say restate. So he tried to restate the case outstanding triangle. What is the reason? If you go through that paper, it has a lot of very educational and very like intelligent, like the concept there. So please read the paper. Anyway, here I'm gonna show you what they did. And there is a case outstanding figure. You can just, subtract the cumulative paid loss triangle from the reported, the claim triangle, and you can get unadjusted case outstanding figure. And also, you should have a, like open claim count at the same triangle. And if you divide this unadjusted case outstanding triangle by this open claim count, you have like unadjusted average case outstanding. And when you try to come up with the trend factor based on the whatever methodology, here like Berquist Sherman use regression, and you have to always be careful. Do I have a unit statistics, right? So this one we don't do apply the regression on an aggregate like case outstanding value, because how many like open claims underlying there. So that's why we divide it by there. And they just apply the exponential regression. So when you look at it, it was like this one is a independent variable, and this amount like this. So when you look at it, like like diagonally, the most recent calendar year, second most calendar year, something like that. So if you do the exponential regression like this, and this is independent variable and dependent variable, response variable, and also like new thing. The reason why I just put it like this is that I try to get the like increase ratio. When you use exponential regression, and each and every year, when you calculate the increasing, the growth rate, they are all the same. That's why it captured like that. So in here, first development, period, there is a 15.6% trend. And second development, 29.5. So number of elements gets reduced by one, right? 31.1%, 34.2%, which is quite a lot. And if you go much later development, but still there is only a small data set. You have a very stable around there. And the goodness fit is that this is like R square. And out of here, like you know, like you cannot just average of all those. And probably Berkshire Sherman thinks that you know earlier earlier development is the most like representative. So they chose 15%, right? Here they're very like conservative here. I mean, we can choose, like higher trend point, but you have to like, justify it why you select 15% as a trend factor. And once you have that, right now, uh, oh, they just examine the same exponential regression by the average premium. Average premium, how you can get it? Like, let's say the paid loss triangle divide by the closed claim count. Here it doesn't show that, but But later in this part, you can have a look at it. This is also one closed claim count, average paid loss. And we can find, let's say, the trend factor. But as you look at it, especially for the earlier development period, and it's like there is a huge discrepancy. It's not that stable. So he chose, uh, like he chose trend factor from unadjusted average case outstanding. So I would call it, he used that trend factor 15% to detrend the average case outstanding. So only the most, like reason diagonal here is the same as unadjusted average case outstanding. And then formula itself, take the 15%, the trend factor that, like that is selected, and instead of multiplying, we just divide it. So it is called, like detrend. And I can restate the historical, except the most recent case outstanding, the average number, and back 1 year, 2 years, second year, like 3 year, 4 year, we did trend using that 15%. And also I've got like what? This is C20. I just get the, like reported loss, excuse me, reported loss amount. And then here probably I apply the, like adjusted case outstanding, average case outstanding, this detrended one, times the open claim count, right? Here, probably. And plus this one, the open claim count, right? So times, so adjusted case outstanding, the average case outstanding times open claim count plus paid loss. And that's what I got here, adjusted reported claim. And after that, I apply the loss development method with the given adjusted, restated reported claim. And the same setup, selection here, simple average, all 8 years. And then I compare, right? So this is just given data. And I took it from the, adjusted reported claim triangle. I got this number. The total is the same as this one. But the, like cumulative development factor, loss development factor to ultimate, original unadjusted reported, claim triangle, and this is paid loss triangle. Adjusted reported like this, plus smaller. So when you compare the original, like unadjusted, PLDM, ILDM shows like 22% like a discrepancy, huge back. But when I do apply loss development, like method upon the adjusted reported, and that shows us this amount. It's even smaller than the PLDM, right? It is kind of too early to make a conclusion, but when I restate the historical triangle based on what case outstanding, right? And that shows like this smaller, let's say, ultimate figure, which is quite significant. I mean, so this is the first like adjustment that they have done. So original thinking is that what if this line has like a lot of fluctuation, volatility there, even though I include 8 years of data, but still 8 years is not enough to, come up with the ultimate. The development period is probably like a little bit longer than 8 year. But anyhow, there is a different, let's say, claim process or underwriting process. All the contract for last 8 years are not homogeneous. And also there's some regulatory change or, macroeconomic or like socioeconomic differences, everything's in it. And when you look at the triangle and link ratio, it is like, ups and downs and it flies all over there. So when you say, I'm not looking at the apples to apple according to different accident year, especially, and also like, like the claim process or like claims department strategy or management like the varies. So like development pattern is not all the same. So with the given data set, it's kind of hard as a consultant to validate your own selection. Even actuaries at their company is kind of very challenging to come up with the like loss development factor to deterministically project the ultimate value. So this is how the first adjustment is done in order to use loss development method. Here, what? Reported loss, right? So ILDM, and that adjusted ILDM shows even smaller value than original unadjusted PLDM. So this is a very good example of what they have done. Like what? Back in 1978. When you look at the accident here is 1976 is the most recent one. So probably it takes like probably a couple of years or a year later to publish that paper. So this is the first adjustment that I would like to share with you. Actually, that's just starting. So when you look at that book, and this one is not like recognized or like honored in an actuarial society, especially in North America, because like when I first started working back in 1997, and the probably popular concept is that don't touch any data. It is like regarded as like, you know, don't manipulate the data in order to like, like make your own conclusion regarding IBNR amount or ultimate loss amount, because you have to be like fully based on historical data, whatever happens there. But when Friedland published, like her book, she included in the last part on a like basic technique this Berquist Sherman, because she thinks it's one of the very like sophisticated way to come up with the best estimate of future, let's say, the ultimate loss or IBNR. And that book was published probably close to 2029 or 2010. So when I went back to Canada, it was released quite recently. And then I'm pretty sure at the time, no company has ever used at Berquist Sherman. But after like 4 or 5 years later, in the annual reserving seminar in the US, that the gentleman, like Sherman, was invited, and everybody says, like he should be honored. And he added more questions. When actuary is working on the reserving, we should ask, like original paper, there's some questions that you should ask for, claim manager or accounting or underwriting or any other, like executive to gather all the basic information of what's going on to try to figure out and then reflect those informations to understand, like the triangle dynamics, and it's going to help you to set up the probably the loss development factor. But during the seminar, like probably early 20, like 12 or 13, and he was invited and he gave a very short address, and he added some of the, like additional questions for any reserving actuary ask, the other executives to support his selection. I recall that time I was working in Canada, and also there are a lot more adjustment in the later part. This is one of the simplest and easiest adjustment to restate the historical case outstanding loss amount, because like the main subject here is case outstanding loss amount is not adequate, doesn't seem to be adequate. So how can we adjust or restate the previous case outstanding amount? Here is one of the techniques that you can use before you come up with the loss development factor, which is a parameter, or the one of the most important assumptions there. So, just remember it. I tried to make, like probably 3 or 4 different videos. If it is too long and you might get, bored or something, so I make it, like 3 or 4 videos for the Berquist Sherman. The main topic is that how or what kind of adjustment we can do to come up with the much better estimate of parameters or assumptions. Okay, thank you and see you later.